Hey guys, Mr. Smith here with another video lesson. In this video lesson, we're going to refocus on an algebraic way of solving linear systems that I teased out in our last lesson. And then moving forward, we're going to move away from solving linear systems by graphing into the more practical and repeatable solving with algebra. And today is one method of solving linear systems with algebra. It's called solving with substitution, the method of substitution. So let's get started. Before we get the ball rolling, let's just make sure we're good with our previous stuff. Can you solve the linear system I've given you here by graphing? So if you want to treat this as a bit of a warm-up, you can pause the video and give that a try, just as a bit of a self-assessment, see where you're at. As usual, you can follow along with me too. So the first guy, y-intercept of -7, and then a slope of 2. So we've done a lot of these, so I'm just going to maybe not be as like draw the whole lines in this time per se. I might just maybe use x's, and once I find a point of intersection, I'll probably just call it a day. And a half times x plus 2. So our second line here, I might actually use an x, and then our slope is a half. So up 1 over 2, up 1 over 2, up 1 over 2. Yeah, there it is. There it is right there. Our point of intersection is, in this case, it looks like 6, 5. So 6, 5 is the solution to our linear system. Of course, this is an easy one to check. Plugging in x equals 6, 2 times 6 is 12, subtract 7 gives you 5, y is 5. A half of 6 is 3, 3 plus 2 is 5. So we are confident that is the solution here. Excuse me. So clearly this is one of our a linear system that wasn't too bad to graph as long as we had a grid, easy enough to read off the answer. But recall we did look at values where not every linear system had other integer values, so whole numbers, and some linear systems had solutions that would be off of a grid that we're trying to use. So this brings us to an algebraic method. So we call this method the method of substitution. And this is our first kind of algebraic way to do this. If both equations are set up in the form y equals mx plus b, you can set the y's equal to each other. So you can set the equations equal to each other and then solve for x, finding an algebraic solution without having to graph. So what we're going to do is we're going to try it out with our linear system from above, the one we just did by graphing. So let me just flip back. So 2x minus y equals 2x minus 7 is my first equation. You guys have this in front of you. I don't just have the PowerPoint. And y equals 1/2 times x plus 2. That's our second equation. All right, so what our strategy says is we are going to set these equations equal. Set equation 1 equal to equation 2. What does that look like? Well, equation 1 on the right side is 2x minus 7. And equation 2 on the right side is 1/2 x plus 2. All right. And we can do this again because it's y and y. Those are equal. That means the right-hand sides can be set equal too. And this is an equation where we can use some of our various strategies to solve. We do have a fraction there. So let's clear it. In this case, it's only one fraction. So we're going to multiply the entire equation by 2. And I'm going to visualize it that way. I'm going to put a bracket around the entire equation. And then we'll multiply it in. So 4x minus 14. 2 times a half of 2 is just 1. And 2 times 2 is 4. Now I should say we already know the solution to this linear system. So when we solve it algebraically, we better get the same x value and y value. We should get x equals 6 and y equals 5. Let's continue and see if we get that. So we'll subtract x from each side. At this point, we're just solving a relatively simple equation. So 3x minus 14 equals 4. Add 14 to each side. Again, you can shave off steps if you're comfortable. 3x equals 18. And look at that, 18 divided by 3, x equals 6, as we expected, right? Now, this gives you the x value. If you want to find the y value, we have to use one of the equations. So we are going to take x equals 6. We're going to sub x equals 6 into, it doesn't matter which equation you put it in. I would advise pick the one that you think is easiest to work with. I'm going to pick equation 1. Y equals 2 times 6 minus 7, 12 minus 7. Y equals 5. And maybe you can make a little concluding statement here. The point of intersection, the POI, is 6, 5. And we got the same answer we got by graphing, but we did it purely algebraically. And I would argue none of the things we did here are really overwhelming in terms of difficulty. We set the two sides equal to make an equation. That level of equation isn't too bad for us to solve, especially having done the grade 9 course and reviewed things and taking the grade 10 academic course. This should be manageable. Yeah, just a little bit of work, but nothing overly complex. We can do it. I'm really confident that all you guys can do this. All right, now let's do some examples together with this new idea. So all of the examples we do in this lesson, the lines will be in y equals mx plus b form. And so you'll be able to set them equal and use this method. Also, as we continue to tie things together, I'm going to get you guys to graph these lines as well, just to reinforce that skill. And it's actually nice to know what the solution is before you start solving the problem. That means when you get to the end, if something's up, you can go back and find a mistake. So let me graph line 1. Y-intercept is 4. And as usual, you feel free to pause the video and try this on your own. I understand that some of you guys will probably catch on pretty quick, and you might not need just to watch the whole video and just see me talk through the examples. You can work through the problems, and if you want to click through the video and check your answers, if you feel you're at that level, that's great. And the slope is minus 3, so down 3 over 1. Down 3 over 1. Fill up my graph, go back the other way. All right, and negative x minus 8. So minus 8 is the y-intercept, and our slope is negative 1. So down 1 over 1, I see what's happening here. And then I won't go back too far because as you guys can see, as I go back, these lines are not getting closer together as I move back up and left here. They're going to meet somewhere, but it's off of my graph. It looks like some positive x value and some large negative x value, negative y value. So, I told you guys to try and solve this. You know what? This is one of those examples where the solution's off the screen. But luckily now we have an algebraic method. So let's try it out. I'm just going to start the solution. We're going to set equation 1 equal to equation 2. So you guys have those visible to you on your page there. So I don't need to rewrite these guys. So we have negative 3x plus 4 and negative x minus 8. All right, set it up. Now we'll solve this equation. No fractions to deal with here. We'll just use our solving by collecting method. We'll add x to each side, add 1x to each side, collect those. We get negative 2x and plus 4 equals negative 8. We'll subtract 4 from each side. Negative 2x equals negative 12. And divide both sides by negative 2. Show that step if you'd like. We get x equals positive 6. To find the y value, sub this x value. So we're going to sub x equals 6 in either one of the equations. So I'm going to sub it into, I think equation 2 looks easy to use. So we have y equals negative x minus 8. So I'm going to plug in x equals 6. So negative, this is like negative 1 times 6, or just negative 6, showing an extra step there. And we get that y is equal to negative 14. So our point of intersection is 6, negative 14. Now, flipping back to our graph, it certainly seems reasonable for that to be the point of intersection. 6, negative 14. It seems to fit pretty good. I think we're pretty confident we did that right. All right, so another example in the books. They're both y equals mx plus b. Set them equal and solve the resulting equation for x. Plug into one of the other equations and solve for y. You've got the point of intersection. One more. So try solving this one by graphing. And then we'll do it by the method of substitution as well. So what do we got? We have 1/2 x plus 4. So plus 4, and then up 1 over 2, over 2. So again, our focus here is not solving by graphing anymore. It's solving using algebraic methods. So I'm just going to put dots and not worry too much about labeling. Just want to get an idea of where the solution is. All right, so negative 5 for the second line, y-intercept, up 7 over 2. Okay, I better be careful here. So up 7 over 2, and then up 7 to 9 over 2. All right. So maybe I will just for this one. So hopefully what you can see is that there's no nice point that these lines are going to meet at, right? So I'm not using a ruler. But even if you were using a ruler, there's no common point with whole numbers. It's somewhere in there. So it's around 3 and looks like around maybe 5.5. But we don't know for sure, right? Because it wasn't at a perfect corner point. And these little squiggly marks I use is a tilde, and sometimes I use those for approximately equal to, because right now we don't know for sure. We know it's about 3 and about 5.5. So it'd be great if we could find a way to get precisely what the point of intersection is. But again, we do, because we have our new method, right? Let's set those two equations equal and find out where it is exactly. So we're going to set 1 equal to 2. So I'm showing all my steps here. As you're doing your work, you can shave off a few steps. You know, if you're doing practice question over practice question, just doing a lot of practice, it's not horrible to shave off a few steps. Of course, if you're writing out work that you want to present to your teacher or hand in or is being evaluated, then you want to maybe take the time to do a good job. Show your steps. All right, so here's our equation to solve. We have one fraction. Well, we have two fractions, but it's the same denominator. So here, multiplying by 2 is going to clear our fractions and make this one easy to work with. Let's do that. 2 times 1/2, that's just 1. So 1x plus 4. 2 times 7 is 14. Divided by 2 is 7x. And then 2 times, hopefully you caught, if you're screaming at your monitor, because I missed. I didn't do 2 times 4. So 2 times 4 is 8. 7x. 2 times negative 5 is negative 10. All right, let's solve this equation. I'm going to just stick to my usual method. Subtract the x's, or in this case, grouping the x's on the left-hand side by subtracting 7x. So that leaves me with negative 6x plus 8 equals negative 10. I will subtract 8 from both sides. Negative 6x equals negative 18. And if you divide by negative 6, x equals 3. So prediction was actually right. They do actually meet at x equals 3. But what's the y value? It was between 5 and 6. It looked like 5.5 was a reasonable guess. But let's see. So let's sub in. I'm going to sub into equation 1 this time. I think that looks easier to work with. So sub in 1. So y equals 1/2. We think that x is equal to 3 plus 4. All right, so a little good talking point here. So we are multiplying these fractions. So it's 1/2 times 3 over 1. That gives us 3 over 2. We multiply the tops and bottoms. So 3 over 2 plus 4. Now, 3 over 2 actually gives you a nice decimal. If you divide 3 divided by 2 on your calculator, you're going to get, so I might just set it up this way if you'll maybe get it down too. So at this point, 3 over 2 is 1.5, and 1.5 plus 4 is 5.5. So that is exact as a decimal, which is great. And it works here because 3 over 2 divided by 2 gives you a nice decimal. But if that fraction was, say, 5 over 7, 5 over 7 does not give you a nice decimal. And in that case, we want to leave our answer as a fraction. So I am going to add these two numbers together by adding fractions. So 4 is like 4 over 1. And to add fractions, you need a common denominator. So 2 is a good choice here. 3 over 2. 4 over 1 as a fraction over 2. It's equivalent to 8 over 2. And now I can add these. 3 halves plus 8 halves is 11 halves. And you can check for yourself. 11 halves, 11 divided by 2 is 5.5. They're the same thing. But, in your textbook, moving throughout your high school career, if you want to keep taking the highest level math course like you're doing right now, you're going to have to be okay with fractions. And here the point of intersection, we would say is 3, 11 over 2. 5.5 is not wrong. You could say 3, 5.5. But again, that was a nice fraction. If the denominator was things like 7 or 13 or 11, then you're going to get nasty decimals and you should leave your answer as a fraction. So I want to encourage you to try and start leaving your answers in exact form as fractions, because you're going to see that checking answers in your textbook, for example. All right, so we have several examples in the books solving a linear system where the point of intersection was off the page, or where it was a decimal or fraction value. So we've got lots of experience now, and you guys just have to practice and just kind of master the skill. Moving forward, we're going to revisit substitution, looking at linear systems where the lines are not expressed in the form y equals mx plus b. Because if they aren't, you can't set the two sides equal to each other. We need to tweak our method a little bit. So how can we solve linear systems where the lines are expressed, in other forms? And that's for our next lesson. Until then, guys, have a great day. Hope you're staying well, and we'll see you soon.